Okay, and now I'm going to solve the same problem, but using the way that I really prefer to think about it again, which is finding a solution to the corresponding homogeneous equation, and then finding a particular solution to the non-homogeneous equation. So again, I'm going to start by rewriting this in the following way: x prime plus t plus 1 over tx is equal to 1. Okay, so now what I'm going to do is look at the corresponding homogeneous equation, which in this case is x prime is equal to minus t plus 1 over tx. I divide both sides by x, and I get that the left-hand side is equal to log x prime, and this is equal to minus 1 over t. I take the antiderivative of both sides, and what this tells me is log of x of t, log of x of t is equal to minus t minus log of t plus c, or in other words, x of t. This is the solution to the corresponding homogeneous equation. This is equal to a times, so I raise both sides to the power of e, and what I get is a times e to the minus t over t. Okay, or maybe you want to write this as you can also write this as a over e to the t times t, however you want to write it. Okay, now for the particular solution, remember I look for particular solutions of the form xh of t times x of t, where the x is unknown. Okay, now if I plug this back into this differential equation, what this is going to tell me is this is going to be xh of t times x of t is equal to 1. Or in other words, since xh of t is equal to a over e to the t, remember I just need one homogeneous solution. So I'm going to pick a is equal to 0, or sorry, there should be a derivative there. So this gives me x prime of t is equal to te to the t. And so now x of t, if I take the integral or the antiderivative of both sides, this is what I get. And again, this is integration by parts. So u is equal to t, du is equal to e to the t dt, du is equal to dv is equal to e to the t dt, and v is equal to e to the t. And so this is uv, which is te to the t, minus the integral of dvu, or vdu, which is e to the t dt. And so this is te to the t minus e to the t. All right, and now that is what x of t is. So now the particular solution is going to be that times the solution to the corresponding homogeneous equation. So then xp of t is going to be this divided by te to the t. So this is going to be 1 minus 1 over t. And now the overall solution to the whole differential equation is going to be this particular solution plus the homogeneous solution. So the general homogeneous solution is a over te to the t, and I'm going to add 1 minus 1 over t. And so this is the general solution to the non-homogeneous equation, and it's exactly what we got when we did it the other way, which is good because doing different ways should give us the same answer.